Hello, my name is Peter Phelps of Phelps 3D, and in this FreeCAD 016 tutorial I'm going to do something a little different. One of the ways I've learned to use FreeCAD better is to take textbooks from other modeling programs, like this one from Solidworks 2010, and go through their exercises and try to figure out how to do them in FreeCAD. So what I'm going to do is pull some exercises from this book here by William E. Howard and Joseph C. Musto, and I've already done a lot of the work to convert it over, 'cause all the exercises in this book are in inches and they do diameters rather than radiuses and etc, etc. So just to get on to it, I'm taking in this video two flange exercises that they had, and we'll be modeling that in this tutorial. So I'm in part design. I'm probably going to do, because of the way that SolidWorks does its modeling, the part design workbench is the closest to the way it works, although they talk about moving planes around and stuff to make certain parts. I'm not going to do that. That's more than, I don't need to create separate planes in FreeCAD to do these parts. So what we're going to start off with is part design, create a new sketch. I'll do it on the XY plane and say okay. And we're going to start out just drawing a circle, sketching a circle. And then hit escape. And this part is supposed to be 5.5 inches in diameter. That converts to 2.75 inches in radius, which then converts to 69.85 millimeters. So 69, oops, my number's on, 69.85. Enter. And we're going to close that. And we're going to pad that. And it's supposed to be 3/4 of an inch, 0.75 inches, so that converts to 19.05 millimeters. Okay. I'm going to select the top of this, create a new sketch. Try to make sure I hit that middle. This one is supposed to be 2.75 inches in diameter, which converts to 1.375 radius, which then converts to 34.925 millimeters. And I'm going to close that. Then I'm going to pad that one. It's supposed to be 2.25 inches, so it will be 57.15 millimeters. Okay, and then we're going to click the top of that one, create another sketch, another circle. Escape, select that one. That one is supposed to be 1.5 millimeters diameter, so it's 0.75 inches radius, which converts to 19.05 millimeters. And in this one, we're not going to pad, we're going to pocket, and we're going to say through all. Say okay. Now we've basically got our simple flange here. Okay. And then they want radii, but I like to do cuts before I add the radiuses. So, but we could try this. Let's see. Click that. Create a sketch. Add a circle. Zoom in a bit. And so where the holes are supposed to be, the radius of that was 4.25 inches in diameters, which is 2.125 inches in radius, which then, if you click the middle and click that, and make a distance, it converts to, it's almost right where it need to be, 53.975 millimeters. And the hole is a ½ inch, so that converts to 0.25 inch radius, which then converts to 6.35 millimeter. And we're going to close that. And we're going to pocket and say through all. Say OK. And then we're going to say 4. And say OK. What we did is we created a polar pattern of the pocket. So now we have our holes. And then we are going to do a 0.25 inch radius on all 3 of these lines. This one, if I can get that one, come on. There we go. Come on. Okay, so I got all 3 of those selected. And we're going to fillet those. And it's a 0.25 inch radius, so it's 6.35 millimeter. Say OK. And then we want to chamfer the inner holes there. And it's a 0.08 inch radius, so for our purposes that's going to convert to 2.032. Say OK. And so then that basically is your flange. Now, I don't know if I've really talked too much about parametric modeling. It sounds like a big, huge term, but when it comes down to its most basic form, it just means that there are parameters, settings that you can change, and then it will modify the design you've completed. So in their example, and I didn't say this, but the exercise for this began on page 11 of the book. In their example, they then take and modify the parameters to modify the design. So one of the parameters is to change the radius of the base part of it. So what we can do is just go back into the sketch, and we still have the radius over here. They wanted to change it to a 7-inch diameter, so which means it's a 3.5 inch radius, which that then converts to 88.9. And we can say close, and boom, we've got a much wider flange. Then they wanted to change the holes, so all we have to do is go back into our polar pattern here, change the 4 to a 6, and boom. And that's pretty much, oops, but then see how it modified the fillets, and the chamfer's gone. This is an issue with the FreeCAD. FreeCAD likes the fillets and all that to be done. It's like the last step. So if you go in here and you modify them, you're most likely going to have to go and delete. Oops. And what was that again? That was the 6.35. And then we're back to where we should have been. Don't ask me. Yeah, they just, FreeCAD wants you to do that as the very last step. Going in and modifying things will almost always break the fillets and the chamfers for some reason. Sometimes it works. Sometimes it's just fine. But sometimes you're going to have to go back and redo it. And it wasn't that hard. It's just a bit of annoying that changing the parameters then change the actual object. So that's the first flange, and I'm just gonna save. Now I probably wouldn't actually 3D print that unless I absolutely had to, but this is just to show that you can go in, use books that are on other topics, and then try to convert them here in FreeCAD. I'll create a new folder for this. And I'm just going to call this Chapter 1 Flange. But if you wanted to, you can take the chamfer file, export, and I would run it through NetVeb, but I'm not going to do that right now. What I'm going to do is skip on over to the next flange. Now, I'm going to do this one a little bit differently. Mostly because I'm going to want to create 2 different sketches for this. So instead of create a new sketch, I'm going to go the XZ plane and say OK. Then I'm going to sketch out basically sort of an L-shaped object. Connected those. tricky part is both of these are going to be slightly bent in. So one of the first things I'm going to do is anchor this bottom to this. Oops, I thought I had. Anchor that to the, so that this line stays intact. I'm going to zoom out a bit. This point to the center has a, this is supposed to be 6 inches, so we divide that in 2, that's 3 inches for the radius, so it should be at 76.2 millimeters. And then this point to here is supposed to be 1.8 inches in diameter, so we divide that by 2, we got 0.9 for the radius, and then it's 22.86 millimeters. Okay. And then we have another figure for here to here. That is 2.2 inches. So that's divided by 2, it's easy, 1.1 inch radius. And that converts to 27.94 millimeters. Alright, and then the thickness or height of this part here is just 1/4 inch, so 6.35 millimeters. Oops, I think I hit 4. Sorry. Alright. Now, this one here, wow, we don't want, so we want to take and make sure that this here is the same thing. Oops. Sorry, folks. 'What did I hit? What did I type? I must not have put the period in. .35. There. Sorry. It has the same distance. And this one here needs to be straight. Okay, and the fun thing is going to be these two here, this one, they both need to have a 2-degree angle. So what we can do is we can click this to this. Now 90 degrees would be straight. we want it to be just 2 degrees. So we're going to set the angle to 88. And then set the same thing from here to here. And make sure this is flat. So it's just slightly bent in. Now we're going to add some fillets. And now we're going to have to try to set the heights back so they stay what they were. Now I'm going to set this one so it stays the same distance as it currently is. Just okay. Whatever that is, it doesn't matter. I'm just trying to fix that point so that when I click this and I give it a radius, and this one they wanted the 1/4 inch radius, so it's the 6.35 millimeter. Then we gotta go in. Let's set this point here. What was that? It should have been 27.94. Set that radius. We're going to actually set both of these, this radius and this radius are the same. I'm not sure if I can do that. Come on. Let's go ahead and just set this one. 3.175. Now see how that one jumped up? That's why I needed to anchor and redo the thickness is 6.35. That one, see number 3.175. And see that suddenly jumped higher. It's just not supposed to. That was because I set the height based on from here to here, so I need to make that height. And that was 38.1. Oops, doesn't like that. Okay, something is conflicting with it. What is conflicting? because it looked like it made this piece higher than it should have been. I'm not sure what's conflicting. It's saying it's fully constrained. Okay, well, I'm just going to leave it like that, as long as, let's see, what is this number? 34, says it has a redundant constraint, which is 25. It should have been taller than that, 34.9. If the one part is 38 thick, yeah, something's not right. Sorry. Which one was these? I wish they had numbers. That 24, well, 24. I don't understand why it's saying it's constrained that way, but I don't see anything that what is constraining it that direction. I'm sorry, folks. I'm at a loss as to why that one's constraining that. Oh, here maybe. There's something, there's an arrow there. Where's the, oh, there it is. No, that's that. This is the fun. I don't see anything that should be constraining it. It shouldn't still be a fully constrained sketch. I should be able to take this thing and move it. The only constraints on that are these, or your angles. You know what? I have no idea. I'm gonna just go ahead and go with it because I'm gonna spend too much time trying to figure out why. I would have to rebuild it just to see why it's doing that, because I should still be able to change. See this point here? The height. I should be able to change the height of this. And there's absolutely nothing constraining that part of it. But it's telling me that that's changing that is invalid. So I have no idea. Well, let's get on, because otherwise I'm just going to sit here and play with it forever. We'll just say that's good enough. Sorry. I don't know. But then what I'm going to do is create another sketch on the same plane. And this sketch is going to start out as a triangle. want this triangle to match as closely as we can. Maybe overlap just a little bit. Oops. So it comes in and matches into the fillet parts. And we're going to close that one. We're going to take that and we're going to pad that. It's supposed to be 0.125 millimeters, so that will become 3.175. And what we're going to do is we're going to say symmetric to the plane so that it centers it on that line that we just, the triangle. It'll extrude or pad out from both sides of it so it's centered directly on the axis. And then the other sketch, I'm going to create a rotation and say OK. And so now we have one flange and a whole bunch of parts. If we click the pad and we create a polar and well, that didn't work. No. When you see it as red, it's not going to work right. Let's take and delete the pattern. Okay, well, what I'm going to do, because sometimes I have a hard time using these. Sometimes it's easier just to take it and go. Take the pad, create a array, and we're going to go 6. Oops, I forgot to change it to polar. There we go. And so that I can go ahead and make my cuts, etc., I'm going to take that and I'm going to take the array and I am going to change its placement slightly. I'm going to leave it at the z-axis, but I'm going to say 30 degrees. Then I'm going to select this. And we're going to create the holes for it. The diameter for the holes was 4.5 inches, so we divide up to get the 2.25 inch radius, which then becomes 57.15 millimeters. So 7.15. And the holes are 4.7625 millimeters. And we'll close those. Make that sketch pockets through all. Take that pockets and we give it the 6.2. And then we would take this and make it a fusion in part. And there's our flange. I'm going to go back to draft and get rid of the Now, again, here we're going to try to modify it by using the parameters, and basically this one should be a little simpler since all we're really doing is going to change it to 3 and 3. So 3 and then the array, we're just going to change those to 3. And see, this time it didn't break the fillets because the fillets were actually part of the base product. I made them in the sketch, so it became part of the rotation. It wasn't not something that we're modifying on the fly. And then go File, Save, and oh, this exercise was in Chapter 5. It was beginning on page 148, the 5.1 molded flange. So I'll just say Chapter 5 flange. So that's pretty much it. We can run both of those through NetFab to make sure that they're 3D printable. Although I probably wouldn't print one of these, I would probably just go buy one if I needed it made. Sometimes, okay, 3D printing is not cheaper than something that, I'm sorry, not cheaper than something that's mass manufactured. It's great for doing prototyping work to get down what you're just trying to get down what you're doing, but when it comes to actually mass producing something, the good old classic of getting it molded or CNC'd is probably cheaper than trying to do it through 3D printing. So, no problems with that one. Yay! Part remove, part add. No problems with that one. Yay! So those are both probably 3D printable. So I hope that this helps you. You know, you basically just try to figure out how they were trying to do it in the exercise, translate it into how to do it for FreeCAD, and this way you can get more practice on how to use FreeCAD to model certain parts. Thank you for watching. Like and subscribe. Have a great day.